Hi, this is Cliff Nelson from Redwood Tutoring. I'd like to talk with you about logarithms, and in this lesson, I just want to do an introduction. Well, let's start off with a definition. A logarithm, or for short, I might just call it a log, is an exponent. All that a logarithm is just an exponent written in a different form. Here's the way that we write logarithms. Log base 5 of 25. Now notice how the 5 is a lot smaller and lower than the 25. The way we pronounce it is log base 5 of 25. Log base 5 of 25. Now, every logarithm asks a question. This logarithm is asking 5 to what power, or to what exponent, is 25? 5 to what power or to what exponent is 25? Well, you know the answer to that. You know that 5 squared, 5 to the second power, is 25. So we write log base 5 of 25 equals 2. Now, how about this one? If I have log base 2 of 8, well, this is also asking a question. It's asking 2 to what power is 8? 2 to what power is 8? Well, I know that 2 to the third power, 2 cubed, is equal to 8. So my answer here is 3. Now, this next one is a little bit more tricky. Here I'm going to have log base 10 of 1/10,000th. Log base 10 of 1 over 10,000. This is asking a question, 10 to what power is 1 over 10,000? That is, 10 to what power is 1/10,000th? See if you could figure this out before I write it down. Well, because the power of 10 is in the denominator, I'm going to have this as a negative exponent. In fact, the right answer is -4. 10 to the -4th power is the same as 1 over 10 to the +4th power. And that's just going to be a 1 with 4 zeros. 1, 2, 3, 4. So the answer to the question is -4. Log base 10 of 1/10,000th is -4. Now, let me go ahead and clear some board space, and then what I want to do is I want to set up a chart. And in my chart, I'm going to go ahead and list the two different forms that an equation could be written in. Over here on the left, I'm going to put logarithmic form, or log form for short. And over here on the right, I'm going to put exponential form. Exponential form. And I'm going to have the same equation written two different ways. So we know that log base 2 of 8 equals 3. We just were talking about that. And we said that that's because 2 cubed equals 8. Well, you might have noticed that I'm actually able to transition from logarithmic form to exponential form using this nice counterclockwise cyclical motion. That is, 2 to the third power is equal to 8. Just doing this nice counterclockwise cyclical motion. This is always going to work when you have the logarithmic expression on the left. So for instance, if I happen to have log base b of x equals y, and I want to convert this into exponential form, well, we use that same counterclockwise cyclical motion, this is going to give me the following for an answer. It's going to give me b to the y power equals x. So one more. If I have log base r of 15 equals t, then this is going to give me r to the tth power is equal to 15. Now, the beautiful thing is that something similar works if I want to convert from exponential form to logarithmic form. For instance, if I had 6 squared equals 36, well, the equivalent logarithmic statement is log base 6 of 36 equals 2. And you might notice how I have a similar sort of counterclockwise cyclical motion starting with the exponential expression 6, then to 36, then back to 2. Log base 6 of 36 equals 2. The same counterclockwise cyclical motion will always work when the exponential expression happens to be on the left. Let me just go ahead and do two more. 5 cubed equals 125. Well, this is going to give me log base 5 of 125 equals 3, using that same counterclockwise cyclical motion. In general, or if I have, for instance, a to the 7th equals q, well, this is going to give me log base a of q equals 7, using that same counterclockwise cyclical motion. This is Cliff Nelson from Redwood Tutoring. Thanks for joining me.